Hi, my name is Gibson Kramer. I'm an application engineer with Promess Incorporated. This is a continuation of our EMAP series, where we look at the different features and aspects of Promess Incorporated's flagship product, the Promess EMAP. The EMAP, or Electromechanical Assembly Press, is used for applications where control, precision, and repeatability are paramount. Today, we'll be looking at two different devices that Promess offers that can help take your application to even higher levels of accuracy and control. The two high accuracy components that we'll be looking at today are overload protected load cells and external digital probes. These components are not necessary for most processes, but can be very useful for the applications that require even higher accuracy than would commonly be needed. We'll start with our overload protected external load cells. Every EMAP comes standard with an internal load cell, which is identified by the silver band at the top of the press. The load cell takes in and reads force measurements in real time. This is what gives the machine the ability to feel how much force is being applied to a particular assembly, part, or function, resulting in extreme precision and repeatability throughout your production run. The internal load cell is highly accurate and works well for most applications. However, there are several circumstances where having an external overload protected load cell can be beneficial to your process. Today, we'll be discussing several different strategies that have been most beneficial to our customers in the past. The first example we'll discuss is using a high force press, but still have the capability of pressing to low, precise forces. For example, a customer had come to us needing a press system for two separate processes. One, a high force application in the 500 kilonewton range, and the second, a low force application in the 30 kilonewton range. This customer could, of course, guarantee precision of both processes by buying a separate press for the high force application and a separate press for the low force application. Alternatively, this customer could purchase one 500 kilonewton press and an overload protected external load cell in the 30 kilonewton range. This would allow this customer to use the same system to press both their high force 500 kilonewton application and be precise enough to guarantee accuracy in the low force 0 to 30 kilonewton range. The second example that uses the same scenario would be utilizing an external load cell to find a touch point. The touch point is a location where the press ram first touches the part. It's important to find this touch point with a low enough force that the part does not begin to press before the application is supposed to. With a 500 kilonewton or 112,000 pound press, it can be difficult to repeatedly detect a 100 pound or 0.5 kilonewton touch point. In this circumstance, it would be very beneficial to use a more precise 30 kilonewton external load cell. The higher accuracy of the external load cell ensures that we find the touch point before we begin to press the part. Once that touch point is discovered, the customer can use the internal 500 kilonewton load cell to press to the high force that the part requires. The final example we'll discuss today is applying multiple load cells to monitor several different locations within the same process. In the past, a customer has come to us with an application where they needed to press 6 metal studs into a wheel hub and guarantee that each stud met its force requirements. Previously, they were utilizing one 30 kilonewton press to press each stud individually. To increase their throughput and efficiency, we recommended that they use one 200 kilonewton press with 6 individual load cells. The individual load cells were able to monitor that each stud was pressed to the required force, verifying each and every bolt. Another way Promess can add even greater precision to a process is by utilizing an external digital probe. The Promess EMAP is already very accurate using its built-in digital encoder, and offers enough accuracy and precision for most applications. However, with an external probe and properly designed tooling, the EMAP can measure down to the single micron range. The ability to add that extra level of measurement, especially when it comes to overcoming tolerance stack-up, is a game changer for processes with intricate part design. Precision measurements, pressing to a part print dimension, and taking that stack-up out of the equation are the real benefits of utilizing an external probe on your EMAP system. Both of these products are easily integrated into the Promess UltraPro platform, allowing for simple calibration and easy plug-and-play connection setup. It is also worth mentioning that Promess Inc. is first and foremost an engineering company. That means when a customer comes to us with a problem, we work with them every step of the way to tailor an engineered solution that fits their application's needs. If you have any questions about adding these products to your process, or would like to inquire about any Promess product, please don't hesitate to call at 810-229-9334, or you can find us on the web at promessinc.com. Thank you.